Okay, in this video we're going to talk a little bit about the basics of R. What I'll do first is I'll just introduce a couple of commands in R in case you've never used R before. Most of the material that I got for this presentation comes from the CRAN, rproject.org website. This is the URL, but I also complemented the material with material from the website, other websites that are listed here. So when you get a chance, please take a close look at this material. There may be more details in each of the under each of these links. So let's just dive straight into it. For R, you can use it for all sorts of things, statistical uh, um, manipulations. You can use it for um, collecting data from the web, and you can also use it for very simple things like calculating values, storing values, and using them later on. As a calculator, R is not very useful. However, because I mean you can always use another tool, but just for the sake of demonstration, let me just walk you through some of the basics that you can do with it. So say for instance you wanted to raise 10 to the power of 2 and add 36 to it. To do that, you just go to the command prompt in R and type in 10 to the in this caret raised to the 2 plus 36, and then you'd hit enter and you'd get a number. And you'd notice that here R has given us the answer of it's in of 136. Let me ask you to try this. Try to compute the difference between the current year and the year you started your graduate degree at UNH, and then divide this number by the difference between the current year and the year you were born. After that, multiply this number by 100 to get the percentage of your life that you spent at UNH for your degree. And you can use parentheses if you need to. So this is a nice little exercise to get you working on the calculator feature of R. There is something that you have to note as you use R. If you use brackets or you forget to add a closing bracket or parentheses, you'll notice a plus sign added to the end of that statement. And what you may want to do, sometimes you accidentally forgot to finish a statement, you want to do it again. In order for you to get out of that, you would want to press the escape key. Otherwise, R will still be busy, still be waiting for additional information or additional input from you. So that's just something that you want to note. So um, another important feature that you have in R is the ability to assign values to letters or phrases. You can give the numbers that you use names. So take for instance that example that we just looked at. This example, you just did a simple calculation, but you did not store values for something else later on. Say you wanted to keep track of the date when you started working or you started your graduate program at UNH, but you didn't want to always remember that date. You might want to call it date started at UNH, something of that nature, because you need to use it in a totally different application at some other later date. So um, in order for you to do that, you can assign that date to a letter or a bunch of letters, um, and then later on use it. So in order to do that assignment is quite straightforward. So for assignment, you can give numbers a name, and when you do this, it becomes known as a variable because you can the value could vary at some later time. To assign a number to a letter or a string or whatever, a set of characters you want, the way you're going to go about it is type the name of the letter, an equal sign, and then the number to which you want to assign that you want to assign to that letter. So in the example shown here, you have the number 4 and you want to assign it to A. You'll type in A equals 4. Alternatively, you could type it in a slightly different way. You could assign the number 4 to A by typing A and then the following symbols together, and this would assign the value of 4 to a. Now, it doesn't matter which way you use. This is the more traditional notation that's used. So, if you prefer to go with the traditional notation, you can use this. So, after you want to, if you want to test that a 4 has indeed been assigned to a, if you type in the letter a and you hit enter, you're going to see the number 4. And we can also use a in other calculations. So you can use a in calculations. For instance, if you wanted to calculate to multiply a with another number, you can say 8 times 5, or 8 times 6, or 8 times 7, whatever number you want to multiply a by, and you could get a value for that. So you can see the value 4 has been assigned to a, and when we multiply by 5 here and we hit enter, we get a 20. You can also use you can also reassign a new value to a. So rather than a being 4, you could make a equals the number it currently is and add something onto it and reassign a brand new value to it. In this case, we've assigned a new value to a, such that a is equal to a plus 4. And now the value of a, when we hit a enter, is 14. So you can see how we can assign values to a letter, and then we can use the letter later on in our calculations. So let's say we've created all these variables and we want to get rid of them because we don't want to use them anymore. One way to get rid of an individual variable after we've assigned a value to it is use the command rm. So we type in rm in the name of the variable and hit enter. That will remove it from the memory, and we can use that variable for something else. Let's say we create a bunch of variables. You've got variable a, b, c, d, etc., and you want to get rid of them all at the same time. In that case, you can use the command rm, remove from list, but you have a long list, and here you're telling r to clear everything from the list, clear all the variables from the list. So rm parentheses list equals ls parentheses will clear all the variables from the list. So what I'd like you to do now is to recall that example that we did previously, that you've done previously, where you computed how long the percentage of proportionate time you've been at UNH. But rather than compute it the same way you did last time, what I'd like you to do is assign the values, different values to variables. And so you're going to create the following variables: current year, which is going to have the current year is 2018. The year start, this is the year you started at UNH as a grad student. The birth year, this is the year you were born. And you're going to assign each of those values to these variables that you've created. And then based on that, you're going to compute how much time you spent as a grad student at UNH, and you're going to assign your answer to a variable called percent time grad, right? So feel free to use parentheses or brackets if you need to, but this will teach you how to assign values to variables and then to use those in computation of a given value. So let's move on and talk about the different data types that we have in R. And this is basically a discussion of how we might organize numbers, how we might organize values in R. One way, the way we've been dealing with it so far is assigning values to scalars, and we'll talk about what scalars are shortly. But we can also create vectors and matrices. And a scalar is just a single number. Number 2, for instance, is stored in a scalar. But vectors and matrices, they take on dimensions. So let's talk a bit about each of these in turn. So a scalar is a value that, such as the number 3 or 4 or 5. And a scalar can be stored and it can be used. So take, for instance, a situation like this, where we have the the value a that we had defined before. That was a scalar, right? So we had a equals 4, that was a scalar. If we had b equals 5, that's a scalar. It's only got, it doesn't have dimensions, right? It's just a single value. So that's what we term as a scalar. But sometimes we want to store more than just a single value. We want to use more than a single value. In that case, we might want to create a structure in which we can store multiple values, and that one of those structures is called a vector. So in a vector, we might want to store multiple numbers like 3, 4, 5. We can easily create a vector by specifying C, concatenate, and then the numbers that we want to store in the vector um, inside parentheses. So here we're going to assign these values to a vector, and we're going to call that vector B. Alternatively, we can use the older notation where B and then this symbol, you've seen it before, and then we have C, 3, 4, 5. So here we've got more than one, we've got one dimension, right? We've got this vector, and it's just got one dimension. Another thing to note is that we can actually operate on that vector, and we'll talk a little bit about that here. So if I created a vector called B, and it's got elements such as you saw the vector that we just looked at shortly. B has got each of these elements 3, 4, 5. We could have written a calculation 3 plus 4 plus 5 divided by 3 if we wanted to calculate the mean of the values that are in that vector. Alternatively, we could just take the vector and say we want to find the mean of that vector. So the mean of the vector B, and we'll get a mean. It will give us the same answer as this. So note that we have introduced something new. We've introduced this thing called a mean. This is a function. If you recall in Excel, we have functions, and functions perform operations on a given value. They need the functions that we use need arguments. We need to supply it with arguments in order for it to perform its operations. So in R, we can do the same thing. We can specify a function, and in it we can provide the arguments that are necessary in order to execute that function. Some arguments are required, whereas some are optional. So in the case of mean, you can see mean B. The mean function is expecting at least one argument, right? So within the parentheses, you specify the arguments. So there are lots of different functions in R, and it might be nice to categorize these functions. So some of the functions that are built into R are numeric functions. In other words, they are built to perform operations on numeric values. So say we wanted to find the log, a natural logarithm of a given number, we can use the function log. If we wanted to find the absolute value of a given number, we can use the function abs. So there are many. This list is by no means exhaustive, but it's just a demonstration of the type of built-in numerical functions you'll find in R. Another category of functions that you find in R are character functions. These are functions that are going to operate on characters. Say, for instance, you wanted to find the uppercase. You wanted to convert letters to uppercase. Those letters are strings, right? So you need functions that operate on those characters. And so one such function is toUpper. So you specify toUpper, you'd provide the argument, which is the string that you want to convert, and you'd get a result of the letters converted to uppercase. And again, this list here is not by no means exhaustive of all the built-in character functions in R, but it's just an example. Here I show you an example of converting stuff to uppercase, text to uppercase. There's others, for instance, if you wanted to substitute or replace a given value. You wanted to substitute, for instance, all the n's with d's. In that case, you could use this function, a character function called sub, and you'd specify the arguments that are necessary in order to make that occur. We also have another category of functions that we have in R is statistical functions. You've already seen one of them, the mean, which I demonstrated in the prior slide. And you can see here one what it does, the mean finds the mean of a given object. And in our case, we had mean b, and it calculated the mean. But there are lots of other statistical functions. There's sum, range, min, max. There are all sorts of functions in R that we could use to compute numbers. So what I'd like you to do is to try the following: to compute the sum of 4, 5, 8, and 11 by first combining them into a vector and then using the function sum. So if you recall, originally when we created a vector, we specified a vector, then we assigned the values to it. So it might look something like A equals C, that's the concatenate, open parentheses, 4, 5, 8, 11, and then close it. And then after that, you can simply use the function sum. In other words, your solution might resemble this one. So you have A equals C, 4, 5, 6, 11, and then in order for you to compute the sum, you use the function, a numeric function, sum, a statistical function sum, and you have the number, or the value, the object for which you want to compute the sum for. So other important functions that might be useful to you that you might want to look at, say you wanted to generate a list of 10 random numbers, you can use the function rnorm, right? Rnorm is just another example of a standard R, a function in R that you can use. So you can go ahead and try it if you type in rnorm and you specify the argument, which tells you how many random normally distributed values to generate, and that will generate values for you. Functions have got required arguments, and they've also got optional arguments. A required argument, obviously, as the word suggests, it's an argument that must be provided to R in order for that function to be performed. But there are others that you might want to specify in conjunction with the required argument, that specify additional information that you think is necessary for that function. We can see this example of rnorm. We want to generate 10 random variables, but we want those to have a mean of 1.2 and another mean standard deviation of 3.4. So the argument 10 is required because we have to tell R how many values have to be generated, but the 1.2, the mean, and the standard deviation, those are known as optional arguments. We can also plot data in R. We can create very simple plots. In the example of rnorm, if we use rnorm, we could create 1000 random values and then assign them to the letter X, and then based on that we could tell R, okay, we want to generate a plot of that, and we could use the function plot and plot the value for X, and that would generate a plot that's similar to this one. So what I'd like you to try to do is to plot the variable I, which consists of 100,000 normal random numbers, and assign a mean of 10 and a standard deviation of 3. And then after that, when you've run the code, you probably see something like this. So I equals R normal, and then you specify how many values, the mean, the standard deviation, and then you'd say you want to plot I. And then your chart would resemble the one that's shown here. So another nice feature in R is the availability of a help feature. Also the availability of an example feature. The help feature allows you to get a bit more information about the function, about the command that you've typed in. And it's simple. You type in help, open parentheses, and then the name of whatever you're trying to find help on. So if I wanted help on how to use rnormal, I'd type in help, and then in the parentheses I'll type in rnormal. But sometimes you want more than the help. Sometimes you want information on exactly how to use that function. In that case, you'd use the example function. So example, and then inside the parentheses, you'd put in whatever you want an example on. So if I want an example of how to use R normal, I'll type in example R normal, and that would give that to me. So you might want to try to mess around or play around with the help feature, and I just like you to find the help for the square root function and find an example of how you might use the square root function. And your solution would look something like this. So you type in help, square root, example, square root, and you'd be provided with the following result. So you'd see exactly the help, and then here you'd see an example of how to use square root. Okay. Another very nice aspect of R is the ability to write your own scripts, right? So, so far we've seen scripts that are built in, we've seen commands that are built in R, but sometimes we want to create our own scripts. We've run a set of commands before and we want to keep using them again repeatedly, and we've written all these statements and want to save them and then use them at a later date. Well, we can. We can create our own scripts, we can store them, and then we can execute those scripts. So it's important to remember that R is an interpreted language and it uses command line based environment. And so rather than just type in commands using the mouse and menu, we can write scripts and then we can import those scripts and use them. And you can store the scripts so that at a later date you can come back and use exactly the same script. And actually creating a script is quite straightforward. It's not very difficult. The steps you're gonna follow, we'll outline them shortly. But when you want to run the script, say you've saved the script and the script's name was food.r, the extension you're gonna save it with is R. You just go in and type in source. That's going to say source. You're going to tell it where to find that script. Then you're going to execute the script. You're going to hit enter, and it's going to run that script that's saved on your desktop. So if we wanted to make a file, if we open Notepad, we created a file, and in that file we wanted it to be a script called first script containing, and that script generates 100 random numbers, so it would have the command to run R and generate 100 random numbers and then plot those numbers. Would write in that text file the necessary commands to perform those steps, would take that file and would store it with a given name, first script.r, and then when it's time to run, we'll just specify source first script.r and we'll run and we'll execute that command. So if we took to look at it here, we create a notepad file or whatever text file, and we save it as first script.r, and we specify the commands that we want to run. So test, we're going to assign to test, um, rnorm 100, and then after that we're going to plot test. When we want to run it, we're going to come over here and we're going to type in source first R. R is going to execute the command, and the command says assign, create 100 random numbers normally distributed, assign them to test, and then after you've done that, plot test. So it executes the command and it plots test. So you can try it with any numbers that you like as well, just to get a sense of how to create your own scripts. And some scripts can actually get quite elaborate with many commands. Some scripts we might create them and they might prompt for data and people might input that data and then generate certain things. So it can be quite useful. But let's go back to our discussion on the different data structures that we have in R. Just recall that R, we said that we can have scalars, vectors, matrices. We haven't talked really about matrices, data frames, and lists, but these are some other data types that we might use in R. for different things. And if you recall, with a vector, it was just a one dimensional um, structure. So if you think of these numbers 1, 2, 3, they're just in one dimension. And we saw how we created a vector, right? We said A equals and then concatenate and then whatever numbers we wanted to assign to that vector, A. So a vector is just a collection of values that all have the same data type. And so it's important that every data element in the vector have the same data type, otherwise it's not really a vector. The elements of a vector are numbered, giving a numeric vector, or the character values giving um, a character value. So this is an example of a vector, and you might have another vector that's actually um, letters, but it's important that they be all the same data type. For instance, if I created a vector called B and it had the values um, ABC, then it would be B equals ABC, and make sure that it's in quotes. That's known as a character vector. What you see here is a numeric vector. We can also have things called logical vectors, and a logical vector will contain values that are either true or false, right? So that's what a vector is. It can store numbers, but it's only usually one dimension. Another example of a vector, here we can see we have a vector v1, and it's constructed consisting of the numbers 1, 2, 3, 1, 4, 6, 8, 10. And this is a numeric vector because it contains numbers. And if we wanted to um, to run to see the vector, we just type in vec1, and then we'll see the result from that. Sometimes you might want to reference a specific element in that vector. Elements and vectors can be addressed. Oops, sorry about that. Elements and vectors can be addressed. So each of these elements, you can see like this element is indexed from 1, 2, 3, 4. It's the fifth element. So vector and then brackets 5 gives us the value 10. We can also replace an element in a vector with something else. So in this case, if we wanted to replace the third element in the vector with the number 12, we could say vector third element equals 12. Now the third element was 1, 2, 3. That's the third element. Now we're taking that and we are making it 12. So 1, 2, 3. We've substituted that element in the vector with the number 12. So we've seen how to create vectors with individual characters or individual numeric values, ones, two, three, four, fives, etc. But sometimes you want to create a really long vector, and the numbers in that vectors appear sequentially. Well, we can use the function seq that allows us to create a sequence to create a vector. So here you can see an example. We've created a vector vec2, and is composed of a sequence of values, numeric values, and that sequence ranges from 0 to 1, and that sequence increases by 0.25. So if we were to run this, would run vec2 and would get the numbers from 0, remember, 0, 0.25, 0.5. We're increasing by 0.25 at each time, but we've created a sequence using this seq command or seq function. So another data type that we have is known as a factor. Um, and factors are actually quite interesting in that you can think of them as variables in R which take on a limited number of different values, right? Such variables, some people often call them categorical variables, right? There are many different categories. Like you can see in this case, we've got a factor and it's got males and females, right? These are categories. So a factor collection of values that all come from a fixed set of possible values. A factor is similar to a vector except that the values within the factors are limited to a certain number of possible values. Right? So that's why we call them categorical variables at times. We can go beyond vectors and store our data in multiple dimensions, right? So the other one had one dimension, our vector, it had just had one, two, three. But what if we added other dimensions to the data set? Well, if we had two-dimensional data, right? One, two-dimensional data, and all the values are of the same type, then this is referred to as as a matrix, right? So in terms of two dimensions, we've stored um, everything in rows and columns. And this kind of structure can be quite useful when we want to manipulate data within this structure. If we wanted to reference this value and use it for something else, and then this value or something else, we can store all these values in a matrix, and then we can reference them and use them for certain manipulation. There's also an array data structure that extends this idea to more than two dimensions. So this is two dimensions. An array will extend this idea to more than two dimensions. So matrices are quite interesting. Like I said, I'll show you how to access the different elements in a matrix. But let's say you wanted to create a matrix. To do so, you need the matrix command, right? So matrix or matrix function, and then we also need to specify the data elements, and we need to tell R how big or how large, how many rows and how many columns our matrix has. So in this case we have mat, that's the matrix we want to create, and we're defining it as a matrix, and the data for the matrix is going to be the following values concatenated. And then this matrix is going to have three columns. So it's going to have three columns, and that specifies how many rows and how many columns it's going to have. We have 1, 2, 3, 4, 5, 6 values, right? And it has three columns, so it's going to have two rows. So the argument data specifies which number should be in the matrix, and then the end call specifies the number of rows, or you can use the end row if you wanted to specify it by columns. After we specified it, we can just tell R mat, and it will show us the mat. Notice that the columns are labeled comma 1, comma 2, comma 3, whereas the rows are referred to as row 1, comma, row 2, comma. This is going to be important when we're trying to reference a particular element in a matrix. So if we wanted this intersection, we'd need to know the columns and we need to know the row, or we need to know the row and the column in order to get to this particular element. So here's a little example that I want you to try. I want you to put the numbers 31 to 60 in a vector named P and in a matrix with 6 rows and 5 columns named Q. And a little hint is you can use the seq command. So the solution to that problem, we have P equals matrix, and we're going to create a sequence for the matrix from 31 to 60, and we're going to increment that sequence by 1, and we want to have 6 columns. When we type in P, we're going to see an example of the matrix. So for matrices, we can perform operations similar to in vectors. If you recall, in a vector, we use the sum function as an example. We use the mean function as an example. We can do the same thing with the matrix. We can find the mean of all the values in the matrix. So but before we do that, it's important for us to know that the elements in the matrix can be addressed, right? Like I indicated last time, if we wanted to get to a specific element, so say wanted to figure out element, let's see, which one can we do? Let's do this one. This element here, all we need to know is the row and the column. If we know the row and the column, we can just say mat, that's the matrix, 1, comma 2, and that'll give us this element over here. If we wanted all the items in a given row, so for rows, we specify them with the number first and a comma. So if we type in mat 2, comma, that'll give us all the elements in row 2. If we typed in mat, comma 3, that'll give us 5 and 6, right? Because comma something, that means you're starting with a column. And if you want to calculate the mean of the entire matrix, you just say mean of the mat. So another structure that we have is called a data frame. And data frames are perhaps the most useful for our purposes. A data frame is a collection of vectors that have all the same length, right? So unlike a matrix where you had the different we had the same data type, in a data frame it's just a collection of vectors, and these vectors might be different data types, and you store them, but it's important that it be of the same length. All the vectors should be exactly the same length. So in this case we have this data frame, and we have um, 3 rows. So this one should have 3 rows and 3 rows. And we can use data frames for all sorts of things. So lots of data that you're going to download, after you've downloaded, we're going to want to put it into a data frame. Take for instance, if you wanted to collect data from one example we're going to do is with wines. So information about a wine that we may have is the price of the wine, the region where the wine is from, and say a description of the wine. Those 3 things are slightly different data types, right? The price of the wine is numeric, whereas the description is text, string, and the region where it's from is also text. So in that case, the data structure that we're going to use to store that value is a data frame. The structure that we're going to use is called a data frame, because we can have vectors for each of them. We can have vectors for the price, we can have vectors for descriptions, and we can have vectors for regions, and then store those values, and then we can refer to each of those. So to create a data frame, if we're creating it, we'd specify the command data frame. So we're going to create a data frame called T, and then in that data frame we're going to store these values. So we're going to store an X, we're going to store this vector, and we're going to store this vector, then we're going to store this vector. Notice they're all the same length. They don't necessarily have to be the same type, but they're all the same length. And then when we hit T, we'll be able to access each of those elements, each of those vectors, right? The columns names are X, Y, and Z. And there are 2 ways that you can select specific things, or you can select columns. So I wanted to select the column Z from a data frame and then calculate its mean. Here we have different columns. Say I wanted to calculate the mean of a given column. I just say mean, and then I'll specify the data frame, and I'm going to calculate from the column called Z. I want to calculate the mean. Another way to do it is to specify mean, and then you have T, and then this says it's a column called T. I often find it easier to use this notation, but you can use either one of them. So I'd like you to try the following. Oops. And for this one, I'm going to ask you to turn it in. So I'll make a script file which constructs 3 random normal vectors of length 100. Call these vectors x1, x2, and x3. Then make a data frame called T with 3 columns, A, B, and C, containing respectively x1, x1 plus x2, and x3. and then call the following function. So I want you to plot t and then interpret the result. Okay, and then upload that to my courses. So another data structure that we have that is useful at times, many times, called a list. So it's kind of similar to a data frame, except one thing: you don't have to have the same number of rows, right? So it's a collection of data structures. The components of the list can be just vectors, but each of the lengths of these vectors can be different, which is unlike the matrix that we just saw, right? So, and it can be useful. It can store all sorts of data. Um, in order to create a list, it's very simple, similar to creating a data frame. Um, we're going to say list and then specify the elements in the list. And when we want to reference the list, notice the numbers may vary in the list. This is a sequence 1 to 5. This one's got 2 values. This has just got 1. So we can reference the list by just typing L, and you can see it looks different to a data frame. So to find out what's in the list, you can type in names L, and then it'll tell us what's in the list, or L and then the $sign 5 plus 10 if we wanted to add values to a particular, if we create it here, particular to this vector that we created within this list called 5, we've added the values 10 to each of the values, so we can modify elements that exist in the list. So far we've plotted some values using a very rudimentary plotting technique in R. R has plotting capabilities built in, and we've seen the function plot. So we can either use the existing plotting tools, or we can get more sophisticated and add packages in order to plot, packages like ggplot2. But for now, let's just look at simple plotting and taking that plot that you generated before with a very simple plot to a slightly higher level. So the plot function allows you to specify arguments, which are coordinates x and y. X being the coordinate for the points in the plot, and y the y coordinates for the in the plot. And the y coordinate is optional. You do have other arguments. For instance, you can specify the type of plot, the type of plot that you want to generate. So if you wanted to plot points, lines, both lines and plot, you can specify the following arguments: P, L, B, and there's a bunch of others. If you want more help on this, like we learned, you can use the help function, then plot, and you'll see all the different options you have to draw the plot. So taking a plot of random normal values, we can generate random normal values. We've seen how to do that before. We said x equals our norm 100. In this case, we're just going to write a simple plot, our norm 100. So it's going to generate 100 numeric values that are normally distributed. And now I can specify different things within the plot. I can specify that it should not be just a dots plot, but it should be lines plot. And I can also specify the color of the line, right? So with the command color. So notice there's more arguments that I can add to this plot, and might generate different types of plots that way. So look at the graphics, see what kind, especially in plots, see what kind of additional arguments you can add, and then you'll see that you might be able to visualize some quite interesting charts. Other things that you have at your disposal are the ability to generate histograms, right? So hist, and then with our norm, this generates a histogram of the values that were created here, and then it plots it. And we can add more to this histogram. We can add color, we can add um, um, how big it looks. We can add lots of different features to the histogram or any other charts for that matter. So this is just an example to show you plotting taken to the extreme, the plot function, and you can see there's all sorts of arguments here. So we could plotting multiple lines, right, with different colors and different lines, and that generates this plot. So you can, this is just to show you that you can format plots in all sorts of ways. Nothing important here, but just that you can use the plot function. It's got many arguments that you can use to make interesting plots. Okay, so let's talk a little bit about reading and writing data files. So in R, you can read data from outside. In other words, you can bring it in, and you can write data to an external file, save a file. The writing is particularly useful for us because we're going to want to download data from other websites, and after we download the data, in other words, we're going to read the data in. We might want to do some processing on the data, then send it out. So we want to write files to it. So to understand how to do so, let's first create a data frame called D. And in that data frame, we're going to put the values 3, 4, 5 in one vector, and another one 12, 45, 54. Such that when we press D, we have a data frame that resembles this one that's shown here. So D, and then we have a data frame with these columns and these rows. So if I wanted to write this data file to a txt file, I've got the command write.table. And that allows me to write data data files out. And it's gonna be saved on my working directory, w get get wd, if you recall that. Um, Whatever I save here. So I write table, that's the command I'm going to use. And then what am I writing? A file called, I'm going to write this data frame that I created called D to a file, and I'm giving the file a name, tst0, and it's a text file, so .txt. And then I can also tell it that the row names are false, and this prevents R from specifying row names. The file as currently is, as we specified it, has got these rows, row 1, 2, 3. Notice we only created 3, 4, and 5, 3, 4, and 5, and then 12, 43, 54, 12, 43, 54. But R creates row names and column names. So if you wanted to export the data without the row names, then you need to specify that row names equals false. Otherwise, it's going to export the data and it's going to look exactly like this, right? If we wanted the column names not to appear, we could specify col names equals false, right? So by default, it's true. If we wanted to get data into R, we need to use the read.table command. So read.table, and then we find the file, and it's looking in our working directory. And if we wanted to read the header as well, we'd say header equals true. And then it's going to read the file in. To read a CSV file, right? A comma separated value file. Assume we had a file and it's a CSV and it has 3 columns that are labeled trial, mass, and velocity. And assume that each row comes from an observation during trials called A and B. Well, if it's stored as a CSV and we wanted to read it, if we had the file that looks like this, so we have trial, mass, velocity, and this is the data, and we wanted to read this into R, then we could specify the command read.csv. We need to know the file name, so file equals, and then the name of the file, and then we can have head equals, then this specifies whether or not we want the header, and then sep comma, this says that each of the data elements are separated by a comma. So this will read the file and will store it in this Heisenberg variable that we've created. Right? So that's how would read a CSV file. And when we type in Heisenberg, enter, we'll see the data displayed. We can also generate summary information about the dataset. So we've imported the dataset and we wanted to generate means, standard deviations, mins, max. We can type in the command summary and want a summary of that variable that we stored, Heisenberg. So summary Heisenberg, and you can see it gives us mean, min, max, median, all those stats for each of the columns. Alright, so at this point let's just talk a little bit about classes, and then we'll talk about characters, dates, and I'll introduce some programming tools, and then we'll be done with this chapter and move on. So all this time, I mean most of the time, what the examples that I've gone through so far have been primarily with numbers, right? So I showed you minimums, maximums, sums, counts, all those that manipulating numbers. But characters are also very important. In other words, strings, they're also very important, right? In some cases, let's say we pull a bunch of tweets into R for manipulation. That data is coming in as strings. So we might want to know how to manipulate that type of data. Other data that we might need to deal with are dates, right? So it's not just numeric data. We also might want to deal with dates as well. So it's important we know how to manipulate that kind of data. So for characters, um, it's important that we know that how to store characters. So if I were to type in a equals 3, that stores the number, that assigns number 3 to a. But what if I wanted to assign the word pair to the letter n? If I just typed in n equals pair, I'll get an error because pair is a string, and R, if it doesn't see any quotes, it treats this data as a number, a numeric. And given that this is not numeric, it cannot assign it to this value, you're going to get an error, object pairs not found. So if you wanted to assign a value um, to a variable, then you're going to need to a character to a set of characters to a variable, then you're going to need to use quotes. So m equals apples, quotes, this assigns this value apples to m. For dates, specifying dates, so the easiest way to tell R that something is a date is with the function strp time, right? And let's say I wanted to create a vector that had a series of dates. We could say the vector, name it date, and we're going to need to specify strp time. And we're going to put in each of the dates and then specify the format for the dates so that R knows that it's a date first of all, but also what is what. So this tells R that we have a year value first. After that we have the month, then we have the date, then we have the hour, minute, and second, so that it knows how to interpret each of these values. And now we've stored these into this variable called date1. When we run or call date1, we're going to get each of the values that we've stored in this vector. So Other useful tools in R that will make our lives easier are if statements, for, and also the ability to write your own functions. So the if statement, the if statement we're going to use when we want to check whether or not the particular condition is true. In other words, we're going to use it to evaluate a particular condition, whether it's met or it's not met. If the condition is met, then we're going to want to take certain steps. If it's not met, we're going to want to take other steps. So take for instance in this case, if we wanted to check whether w is less than 5, and if it's less than 5 we do one thing, otherwise if it's greater than 5 we do something else. Just a simple example just to get you thinking about an if statement. So if we begin by specifying a condition, specifying what w is, so w is equal to 3, and then we wanted to evaluate whether or not um, w is less or equal to a given number, we could create an if statement. So if w is less than 5, then we want to make d equals to 2. Otherwise, we want to make d equal to 10. If the condition is met, it will execute what's in between the brackets. So you can see here, we're going to create a variable called x. If w is less than 5, then do this, else otherwise do what's in here, right? So w equals 5, do this set of steps, otherwise do this. So what's happening here is this operator here is evaluating whether or not this condition is true or false. After it evaluates, then it performs the actions that are in this first curly brace if this condition is true. Otherwise, if the condition is not true, it performs the action in this case. And when we started, we specify x is equal to 3, so this condition is true. So if we type in x, it's going to produce a 2. Okay. So the greater than, less than sign are not the only operators that we can use. They're called Boolean operators that we can use to evaluate a statement. There are actually many Boolean or logical operators. There are many operators that we can use to evaluate conditions. We've seen the less than. We can also have less than or equal to, greater than or equal to, exactly equal to is two equal signs, not equal to, that x is not something, that it's x or y, and then x and y. So we can evaluate all these using all these different operators. We can evaluate whether or not a given statement is true or is not true. So another thing that we might want to do from time to time is to perform a certain action several times. In other words, to repeat a given action several times. So if I wanted to print, for example, the numbers 1, 2, 3, 4, 5, etc., I could write the words print 1, print 2, and I'd print each of these, right? Or I could create a loop, a counting loop, that prints until a particular condition is not met. So for instance, in this example, I want to print numbers 1 to 100. I can create a for loop, which is a counting loop. And if I say for the variable I in 1 to 100, so for the variable I, 1 to 100, print I. So it's going to print 1, 2, 3, 4, etc. So a loop allows me to perform an action repeatedly many times. Now, with the for loop, you specify what has to be done and how many times you want it to be done. So we saw in this case, we said for I in 1 to 100. 100 times is the number of times this has to be performed. And then you have to tell it that it should stop, otherwise it will carry on performing that set of steps, and it'll be in an eternal loop. So you want to make sure that you stop it. So in order for you to stop it, oftentimes what we do is we create an empty vector, right? And that empty vector says to the loop, well, when you see nothing, stop. So let's look at this example. H equals sequence from 1 to 8. So this creates a sequence of numbers from 1 to H, from 1 to 8. If we wanted to print the numbers 20, 30, 40, 50, 60, 70, 80 from this sequence H, we could create a for loop and specify that for I in 2 to 10, take those values from the sequence H and multiply them by 10. And this would loop through, because we're using the for loop, it would loop through and loop through and loop through. Everything between the curly braces here, right, is going to be performed 9 times. The first time I is equal to 2, the second element H is multiplied with 10 and placed in the second position of the vector x. The second time I is equal to 3, etc. In the last two runs, the ninth and the 10th element in H are requested, but they don't exist, right? So this empty vector S is created. It's necessary because when you introduce a variable within the loop, R will not remember when it should get out of the loop, right? So you want to make sure that R gets out of the loop, otherwise these steps will be um, executed eternally. So I want you to try this. Make a vector from 1 to 100 and then create a for loop which runs through the whole vector. Multiply the elements which are smaller than 5 and larger than 90 with 10, and the other elements with 1. And then save your work, and you can upload it onto Canvas. All right, so finally, let's talk about writing your own functions. So the functions that we've used so far, like mean, um, sum, all these functions are written by somebody, and then they're built into R, and we're able to use them. But as you know, not then you know there's not an infinite number of functions, and sometimes we might want functions specific to a problem that we have. Let's say every day we're supposed to calculate interest, and we know the formula for interest, but uh, we, we keep calculating, plugging in numbers and computing every day the same thing, and we wanted to make our lives a little bit easier and just write a function and then provide arguments, and then it does the computation without us having to write through the whole formula in order to compute the value for interest. Um, in order for us to make our lives a little easier, we might create a function and then reuse that function by simply providing the arguments necessary for the function. So let's take the example of interest, right? So compute the amount paid on a loan, and this is just simple interest. So the amount, if we recall from some of our classes, principal 1 plus rate times time, right? That's how it compute the amount. So if we wanted to create our own function for interest, we could create a function, call it interest, and then equals to, and then now we tell R we're going to specify a function here. And that function is going to have 3 arguments. One called principal, one called rate, and another one called time 1. I use time1 because time sometimes is a built-in command, so it might mean a different thing to R. So just to be safe, I'm going to call this argument time1. Now R, what it needs to know next is, okay, please tell me how to do this. So for the amount, it's going to be principal times 1 plus the rate divided by 100 times 1. So this is how it's going to compute the amount given these arguments. And it's going to return back to the user an amount. So after that, we hit enter, and now our interest function exists. If someone types in interest, they're going to be prompted to provide the arguments for principal, rate, and time. If they provide these arguments, R is going to take those values and calculate it's going to use this one as principal, calculate the amount, principal, and then it's going to look, oh, this is a rate, plug it in here, rate, and then, oh, this is a time, plug it in here, time. It's got a value, and then it's going to return back this value that it's got from here is the amount. It's going to return back an amount based on the computation, which is that. So now all people have to do is to specify interest, and then the arguments will be supplied. So as a last exercise for this module, I'd like you to create a function to compute compound interest on a loan. And here is the formula. And after you're done with this, please turn in your solution via my courses. Okay, that wraps up this module. Next module, we're going to be talking about applications of R, scraping data from the web.